Hello, my dear students. Welcome once again to our online class. I am your teacher, Mr. Esomnofu Chidiebube. Kindly listen and enjoy with us. Okay, now before I introduce the topic, I want to leave you with these starter questions. It will help you to master the topic at hand vividly. Okay, use calculator to simplify the following. So wherever you are, get your calculator, try to simplify the below questions. You can see square root of 25, you can see square root of 4, you can see square root of 15, and square root of 8. All right. Now, with your calculator, you find out that the square root of 25 will give us 5. No remainder at all. There is no point. It will give us just a whole number. When you get the square root of 4, you will get 2 from your calculator, a whole number, no remainder, no decimal at all. Also, I want you to get the square root of 15. You see your calculator will give you repeated values like 3.87 dot 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 etc. So many of them is repeated. Also, square root of 8 gives us 2.82 dot 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 dot, a lot of repetition. Okay, this leads us into the topic of today, known as sword. So in those starter questions, you will find out that the square root of 25 and 4 gave us whole numbers, but the square root of 8 and 15 gave us recurring decimals. Now, such square roots that begot recurring decimals are called surds. So whenever you get the square root of a number and it gives you recurring decimal values, it means that the kind of square root is known as what? Surds. All right? So this takes us into a very nice topic in mathematics known as surds. S-U-R-D-S, surds. No, 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 no. That is not what I'm talking about. So sword is quite a different thing in mathematics. Now, here are the objectives I want you to achieve by the end of the lesson. So you should be able to define surds. You should also be able to state the rules guiding surds. You should be able to simplify and apply the rules in surds to solve some problems. Now, let's get into the meaning of surds. When the term surd is mentioned, what comes to your mind? A surd is an irrational root of rational numbers. A surd is an irrational root of rational numbers. Now, a brief review of rational and irrational numbers, because it's why it's important you know them for proper mastery of the concept surds. Now, rational numbers are just those numbers that can be expressed as a ratio of two fractions. Why irrational cannot be expressed as a ratio of two fractions. All right. Now, any number that is recurring without repeating is irrational. But if you don't recur at all, or if you recur and repeat similar values, it means you are rational numbers. So now, 2 is a whole number. It is rational. But when you put these 2 inside this surd, inside this square root, it gives us irrational value. 6 is a rational number on its own, but when it appears into the square root, it gives us irrational values because it will keep on recurring. 82 is a rational number, but when it enters into the square root, it gives us recurring values. So you see that all these numbers inside the square root are all rational. But when they appear inside the square root and you want to find their value, they will give you irrational value. That was why I said that a surd is an irrational root of rational numbers. All these numbers are rational on their own. But once they appear into this root, they change to what? Irrational. Just like God gave gave Moses 10 commandments in the Mount Sinai, if I'm not wrong, Also, for proper understanding of source, there are rules you need to obey if you want to succeed. Because if you don't keep the Ten Commandments, I don't think you make heaven. Also, if you don't keep these rules guiding sword, you will not make it in swords. So it's quite important you honestly try to make these rules the part of you if you really want to succeed in swords. Okay, sword A plus sword B will not give us sword A plus B because most of us are seeing that we are having a sword A plus sword B. You think you just add A and B inside the square root. No. Provided that the operation there is plus, sword A plus sword B individually is not the same thing as bringing them together. That's why you see equal sign being cancelled. Also, when it is minus, sword A minus sword B is not also equal to sword A minus B. Then sword A times sword B is not also is equal to this time around when it is times place. Sword A times sword B will give us sword AB. Also, sword A divided by sword B will give us sword A all over what? B. So when it is times and division, you can bring them together. But when it is just addition and subtraction, no. It doesn't hold. Okay, before we get into so many calculations for today's lesson, I want you to understand what we mean by similar swords. When the word similar swords is mentioned, you should know that two swords are said to be similar or like if they have the same sword, if they have the same sword factor. So two swords are said to be similar if they have the same sword factor. What do I mean by same sword factor? When you come to two or more swords and you find out that they have similar number in their square root, in their root, when they have been reduced to their lowest term, it means they are similar. You get? So when two or more swords, having been reduced to their lowest term, are having similar numbers in their square root, they are said to be what? Similar. For instance, you can see the examples below. Sword 5, 7 sword 5, 10 sword 5, minus 3 sword 5. You see that all of them are having the same number in their square root. Because they have the same number in their roots, they are said to be what? Similar. Note, you can only add or subtract similar swords together. The similar swords can be added or subtracted together, unlike swords. So unlike swords or the similar swords are swords that does not have the same number, that do not have same number in their roots. Okay, and they cannot be added or subtracted together when they are reduced to their lowest terms. Okay, now let's get into the simplification of swords. So the instruction is telling us to write the following swords in the form A sword B. We have sword 20, we have sword 27, we have sword 48. We are asked to write them in the form A sword B. So let's go to the solutions. Now, the trick here is to think of two numbers you multiply together to get 20. Those numbers must be a perfect square. You think of two numbers you multiply together to get 20. One of the numbers must be perfect square. For example, in 20, 1 times 20 can give me 20, but between 1 and 20, no perfect square. 2 times 10 can give me 20, but between 2 and 10, no perfect square. But when I say 4 times 5, it will still give me 20. But 4 is a perfect square because the square root of 4 will give us 2. Okay? That's why I chose to use sword 20 as square root sword 4 times 5. Makana 4 times 5 will give me what? 20. Now, but 4 has a square root. 4 is a perfect square. Therefore, when you find the square root of 4, you get 2. So the answer becomes just 2 sword 5. 2 sword 5. Okay. Now, question 2, we are giving sword 27 to write in the form A sword B. You also think of two numbers you multiply to get 27. One of the numbers must be perfect square. All right. Now, so many numbers can be times together to give us 27, but the one we shall use will be 9 and 3 because 9 has a square root. It's a perfect square. That's why I wrote surd 27 as surd 9 times 3. And the square root of 9 is 3. That is why we have 3 surd 3. Now take a look at question number 3. We are given surd 48 to simplify. You also think of two numbers you multiply together to get 48. One of the number must also be a perfect square also. And you know that 16 times 3 is the right number. There could be other numbers that can give you that, but it's only 16 and 3 that is suitable because 16 is a perfect square. And the square root of 16 will give us 4. That's why our answer is 4 surd 3. Okay, having learned that, let us progress into what we call writing surds of the form A surd B as single surds. So you now want to write all these surds in the form A surd B as single surds. And we have two questions here below, 2 surd 5 and 3 surd 3. Now solution for question number 1, where we have 2 surd 5. The trick here is to put the number which is not in the root into a root. For example, 2 surd 5, 2 is not in the square root, so you need to make it to be in a root. But the root form of 2 is just surd 4. The square root of 4, not surd 4, because 4 is not, square root of 4 is not a surd. So 2 is the same thing as square root of 4. I mean that 2 that is outside is the same thing as square root of 4. Hence, 2 surd 5 will give us square root of 4 times surd 5, because square root of 4 has replaced the 2, which is beside the 5. You get? Then, and according to the rules guiding surd, square root of 4 times square root of 5 is the same thing as square root of 4 times 5. This will give us square root of 20. So that's how to write it as a single surd. Problem number 2, we are also asked to write 3 surd 3 as a single surd, 3 surd 3. So the 3 that is outside will also be equivalent to square root of 9. You get? So when you have 3 surd 3, the 3 that is outside, put it in a root form. So the 3 outside turns into square root of 9. Then multiply by square root of 3. And according to the rule guiding surd, square root of 9 times square root of 3 will give us square root of 9 times 3, which is giving us root 27. Okay, so you see that dealing with all these problems are not that difficult. Let's keep on progressing. Pause this video at each point in time when you are confused to understand the particular concept very well, then you can play it and continue. All right, adding and subtracting surds. Let's see how surds can be added or subtracted together. When you have 4 surd 2 plus 6 surd 2, now you must know, according to what I told you ab initio, that it is only similar surds that can be added or subtracted together. You can't add or subtract the similar surds. So this is just like seeing this as 4x plus 6x, where you just add the coefficients. So our target here is to add the coefficients of these surds. We just add 4 plus 6. Don't add the numbers inside, please. This means that I have 4 surd 2, and tomorrow I bought 6 surd 2. How many surd 2s am I having? It's just 10. So don't touch the surd. Just add their coefficient, the number beside them. So this becomes 4 plus 6, which is giving us 10 surd 2. In question number 2, where you have 6 surd 5 plus 7 surd 5 minus 9 surd 5. As usual, don't stress yourself. Just add the numbers beside the surds. Remember, don't add the ones inside. To have just 6 plus 7, then minus 9, all surd 5. And 6 plus 7 is 12. Is 13, sorry, 6 plus 7 is 13. And 13 minus 9 will give us 4 surd 5. So you see that dealing with all these things are not that difficult. Let's continue progressing. Let's test ourselves once more with question number 3, which is asking us to simplify 6 surd 27 plus 2 surd 12 minus 4 sod 75. Now, but the numbers in the roots are not the same thing. They are not similar. So you need to reduce them to their lowest term to see if they are similar. If they are similar, we go ahead and perform the operation. If they are not similar, we leave it like that because you can add or subtract sods that are not similar together. Now, in the 6 sod 27, I will break 27 into 9 times 3. In 2 sod 12, I will break 12 into 4 times 3. In 4 sod 75, I will break 75 into 25 times 3. Now, 9 has a square root, and the square root of 9 is 3. That is why 6 outside is times 3. Also, 4 has a square root, and the square root of 4 is 2. That's why 2 outside is times the square root of 4. 25 has a square root, which is 5. That's why 4 outside is times 5. And 6 times 3 will give us 18, so 3. 2 times 2 is 4, so 3. And minus 4 times 5 is minus 20, so 3. You can now see that all of them are having similar sorts. Then you can go ahead and perform the operation. 18 plus 4 minus 20. And 18 plus 4 is 22. Minus 20, giving us 2 sod 3. Okay, at this point in time, I have to summarize the lesson. A continuation will come up in the next lesson because there are so many things that are in Surd. We just did an introduction today. So a Surd is just an irrational root of rational numbers. There are rules guiding Surds, of course. The rules will help you to tackle some problems involving Surds. Only similar sorts can be added or subtracted together. To write sorts in the form A sod B, you have to think out two numbers that will multiply each other to give us B. One of it must be a perfect square. Remember, a perfect square has exact square root. It's not recurring when you find their square root. Okay, now take down this assignment. Please make sure you do it. It will help you to ascertain if you've actually understood the topic being taught today. So you can see question number 1, 2, and 3 are your assignments. Kindly take them down and make sure you do them. For further studies on this topic, you can lay your hands on the test. Hidden Fact in Mathematics, Best of Mathematics, New General Mathematics, or you can go online on the sites listed below. For submission of assignment and further contact with me, the teacher, you can get me via my phone number 070-6839-4063 or email chuks@gmail.com, Facebook chuks@chukes. Thank you so much for listening. Have a nice day.